Nadia walks along a straight path that goes directly from her house to her grandmother's house. Some of this path is on flat ground and some is downhill or uphill. Nadia walks on flat ground at 5 kilometers an hour, walks uphill at 4 kilometers an hour, and walks downhill at 6 kilometers an hour. It takes Nadia 1 hour and 36 minutes to walk from N to G and 1 hour and 39 minutes to walk from G to N. If 2.5 kilometers of the path between N and G is on flat ground, the total distance from N to G is closest to. Alright, so let's figure out this diagram. So we have N and we have G. And I have no idea what is the exact specification, so I'll just guess. I'll say there's a certain amount of flat land and a certain amount of land that's going to be uphill and downhill. So this part is uphill if I'm going in this direction, and then this part will be downhill. Now if I'm going in the backward direction, this part will now be uphill and this part will be downhill, right? I mean, that's just common sense. And then throughout this question we're going to use that formula, speed is equal to distance over time, or any variation of it, such as time is equal to distance over speed. So let's look at the first scenario, which is going from Nadia's house to the grandma's house, N to G. Time there will be as follows using this formula. First, it's the distance on the flat land, which is 2.5 according to the question, divided by the speed on the flat land, which is 5. And then you add to that the next segment, which is x, in terms of its distance, and when you're going this direction it's uphill, and that speed according to the question is 4. And then the next segment is y, which is downhill when you're going in that direction, so y and the speed going downhill is 6. So there you go, that's the first equation. Now time in that direction they've told me is 1 hour and 36 minutes, and we have to convert that to hours. And when you do, you get 1.6. And this is 0.5. And this is, of course, just x over 4 plus y over 6. This becomes 1.1, x over 4 plus y over 6. And then multiply through by 24 to get a common denominator. Or actually what I'm trying to do is really just get rid of the fractions. And multiply through by 24, I get 26.4. plus 6x plus 4y. And this is equation 1. Now what we do is we do pretty much the same thing, but for the other path, which is from G to N. And for that path, pretty much the same. Time is going to be, again, y, but this time it's an uphill, right, when you're going this way. So now the speed is going to be the uphill speed, which is 4. So it's y over 4. And then x, but this time it's a downhill, so the speed will be a downhill, which is 6. And then, of course, the flat, which is 2.5, and the speed, which is 5. And the time is 1 hour and 39 minutes. Converted to hours will be 1.65. And again, this is y over 4 plus x over 6 plus 0.5. So this is 1.15 is equal to y over 4 plus x over 6. And then multiply through by 24, and you get 27.6 is equal to 6y plus 4x. And this is equation 2. So now that's it. We just have two equations, two variables. We can easily solve for x and y, and then we can add up all the distances to see what the full distance is. Now, I really should let you do this, but I'm a nice guy, so I'll just do it, because at this point it's pretty straightforward. And any way you'd like to do it, you can either isolate for one variable, substitute into another, or you can do what I'm doing, which is manipulate both equations, 4 times 1 minus 6 times 2, right, whatever. So if you do that, you get 26.4 minus 6 times 27.6. And on this side, you get 24x plus 16y minus 36y minus 24x. So this is going to be 105.6 minus 165.6 is equal to minus 20y. So that gives me minus 60 is equal to minus 20y, and therefore y is equal to 3. Substitute that into any of these, either that one or that one, and I will let you do that. And when you do, you get x is equal to 2.4. So now we have to add up the total distance. It's f plus x plus y. The total distance is f plus x plus y. Well, f is given in the question, 2.5. X I just figured out was 2.4. And y I figured out was 3. So when you add those up, it's 7.9. So number 24, the answer is E. Alpha ran at a speed of 21 kilometers per hour from P to Q to R to S, as shown. Florence ran at a constant speed from P directly to R and then to S. They left P at the same time and arrived at S at the same time. How many minutes after Florence did Asafa arrive at point R? So in this question, we are going to use speed equals distance over time. And of course, any variation of that formula is appropriate. For example, time is equal to distance over speed. And Asafa, who might be Asafa Powell, who is the former world record holder for the 100 meters, and Florence might be Florence Griffith Joyner, also known as Flojo, who was still the women's world record holder for the 100 meters. And they are running quite fast from P to S. So the first thing I want to do is figure out the length of PR, because that's going to be needed. And we can use Pythagoras to do that. So 8 squared plus 15 squared is equal to PR squared. And that means that we have 289 is equal to PR squared, and therefore PR is equal to 17. So there we go, 17 right there. Now the most important thing in my opinion in this question is the fact that they are arriving at the same time at S. So that means their time is the same. The time that it takes Florence to go from P to S is the same as the time that it takes Asafa to go from P to S, although they are going in different directions. P to R to S is Florence, her path, and then PQ, then Q to R, then to S is Asafa's path. So first let's figure out the time for Asafa. It's equal to distance over speed. His distance is going to be 8, then 15 plus 7, correct? So that means it's 8 plus 15 plus 7, all divided by his speed, which they give us is 21. So this is 30 over 21, and in lowest terms, that's 10 over 7. So that's the time, and that is in hours. So just keep that in mind. Eventually, we're probably going to have to convert it to minutes. So that takes care of Asafa's time. Now we have to turn our attention to Florence, and we need to figure out her time. And the same formula, time is equal to distance over speed. And her distance is 17 and then 7. 17 plus 7. But her speed we don't know. But that's okay, because her time, which is this, is equal to Asafa's time. Remember, the time that it takes her to go all the way to S is the same as the time it takes Asafa to go all the way to S. So Asafa's time we calculated was 10 over 7, and that is equal to Florence's time. So 10 over 7 goes here. And this allows us to give a calculation for her speed. Cross multiply, you get 10S is equal to 7 times 24, like that. And if you do the math here, you get S is equal to approximately 16.8. All right? So now we get to the heart of the question, which is figuring out the amount of time that it takes for both of them to go to R, only to R, right here. So let's first talk about Florence. Time is equal to distance over speed. Her distance from P to R is just 17, and her speed we just figured out was 16.8. So that is approximately 60. It's approximately 1, but I'm converting it to minutes by multiplying by 60. And I get approximately 60.7 minutes. Okay? Then Asafa, to go from P to R, he has to go down to Q and then over to R. So his time is equal to, same thing, distance over speed. His distance now is 8 plus 15. And his speed we had earlier figured out. Well, actually, no, his speed is given in the question. We don't have to figure that out. And that's 21. So this is 23 over 21, and that's in hours. If you multiply by 60, you'll get the minutes, and it's about 65.7 minutes. So now, it takes Florence 60 minutes to go from P to R. And then, Asafa, it takes him 65 minutes to go from P to R. So, answering this question, how many minutes after Florence did Asafa arrive at point R? Well, it's the difference. The difference between their two times, which is approximately 5 minutes. And therefore, number 22, the answer is E. Jillian drives along a straight road that goes directly from her house to her grandfather's house. Some of this road is on flat ground and some is downhill or uphill. Her car travels downhill at 99 kilometers an hour, flat ground at 77, uphill at 63. It takes Jill 3 hours and 40 minutes to drive from J to G. It takes her 4 hours and 20 minutes to drive from G to J. The distance between G and J in kilometers is... Well, let's draw a little diagram. So we've got J and G. And I don't know the distances, so I'll just say from here to here is the flat. And then the distances, I really don't know. But we'll just call them X and Y, the next couple distances. And we'll just say that when she's going in that direction, the flat is obviously going to be flat in either direction, but this will be downhill and this will be uphill. But then when she's going back in this direction, this will be downhill and this X will be uphill, right? I mean, obviously. So let's look at this scenario first, and we will look at J to G. And of course, throughout this question, we're going to use that formula, speed is equal to distance over time, and any variation of that formula, such as time is equal to distance over speed. All right. So J to G, this one, we're going to look at the time. The time is 3 hours and 40 minutes, so that's 3 2/3 hours. And that is going to be F over 77 plus X over 99 plus Y over 63. And then in a very similar way, G to J, if you look at that, it's 4 hours and 20 minutes, so that's 4 1/3. And that is equal to, again, F over 77 plus, this time, remember, this is now downhill and this is uphill, so we got to make sure that we don't mess that up. So it's going to be Y over 99 plus X over 63. So we can call this equation 1 and we can call this equation 2. So if we equate this now, I think we are ready to do some algebra here. 1 minus 2, I think that will help. If I do that, let's see what I get. I get 4 1/3 minus 3 2/3. And then on that side, I will get X over 63 plus Y over 99. and then minus x over 99 minus y over 63. And then the f's cancel. This guy cancels with that. So if I collect like terms, this just becomes 2/3, and then I'm going to have to use some fractions here to get common denominators and all that. 99x minus 63x divided by 99 times 63. And then for the y, similar, 63y minus 99y over 63 times 99. That's going to be the common denominator there. So now I can cross multiply, and this is going to give me 2 times 99 times 63, and this is going to give me 3 times 36x minus 36y. Yeah. So that means if I factor out a 36, all I'm left with is x minus y, 3 and 36, and this side is the same. And then now I can easily isolate for x minus y. And when I do all that math, 2 times 99 times 63 divided by 3 times 36, x minus y is going to be 115.5. All right. So that's a pretty good result so far. But I am asked to find the distance from G to J or whatever. And that distance, if you remember, was f plus x plus y. Now, how am I going to figure that out? Well, I can use one of the original formulas that I had up there, that 3 2/3 was equal to f over 77 plus x over 99 plus y over 63. This helps me out a little bit. So let's see what I can get with that. I can substitute for x, I can substitute 115.5 plus y over 99. And that's going to be like this. 3 2/3. Okay, so now we got to do a little bit of algebra here. We got to get some common denominators and all that. So let's do that. 3 2/3 is equal to f over 77. Multiply top and bottom by 63, 115.5 plus y. And then multiply top and bottom here by 99, so we get 99y. And this gives me a common denominator of 99 times 63. So this, when you expand it all out, it gives me 7276.5 plus 162y over 99 times 63. And I'll break it up this time since I can bring that over to the other side. And this is 3 2/3. So now this is a number, so I can just bring that over to the other side. And when I do, and I subtract it from this, interestingly, it gives me 2.5. So that's a nice number. And all I'm left with on this side is f over 77 plus 162y over 99 times 63. Okay, at this point I still have two variables, but I can use inspection now. So let's see. Using inspection, let's see what I get. Because that's the only thing I can do when I have two variables. Let's say I let f equal to 77. That would make that 1. Okay, so that would be 2.5 is equal to 1 plus 162y over 99 times 63. Bring the 1 over and I get 1.5 is equal to 162y times 99 times 63. And if I solve for y in this, I will get y is equal to 57.75. And now I kept this in this screen for a reason. We can use that to figure out x, and when you plug y into there, you get x is equal to 173.25. All right, well, now I can go back and figure out what is d. d is f plus x plus y. This is f, this is x, and this is y. And therefore d is equal to 77 plus 173.25 plus 57.75, and that is equal to 308. And there you go, that's the distance. So, number 22, the answer is C. The Canadian Mathematics Competition reception desk has a tray in which to stack letters as they arrive, starting at 12. The following process repeats every 5 minutes. Step 1. 3 letters arrive at the reception desk and are stacked on top of the letters already in the stack. The first of the 3 is placed on the stack first, and the second letter next, and the third letter on top. Step 2. The top 2 letters in the stack are removed. This process repeats until 36 letters have arrived, and the top 2 letters have been immediately removed. Once all 36 letters have arrived, and the top 2 letters have been immediately removed, no more letters arrive, and the top 2 letters in the stack continue to be removed every 5 minutes until all 36 letters have been removed. At what time was the 13th letter to arrive removed? So we have to make a little bit of a list, a table. So I'm going to start at 12 noon, and every 5 minutes after that, I am going to obviously add some papers. So I got 12, 12:05, 12:10, 12:15, and so on. So here we go. Let's start filling in this table. At 12, the first 3 papers arrive, so I'll just label them 1, 2, and 3. And then after they arrive, they remove the top 2, correct? So when they remove the top 2, I'll just circle those. And then we get to the next time period, which is 12:05. When that time period starts, the only thing that's left in the stack is the paper that I have labeled 1, because papers that were labeled 2 and 3 were removed. Now we add the next 3, and I'll call those 4, 5, and 6. Okay? Now we get to the next 5-minute period. And when you do, it starts with just 1 and 4. Why? Because 6 and 5 were removed. And this process continues. So I'll just do a few more, and then I'll fill in the rest, because you'll get the idea by then. Now at this point, at the 10-minute point, we add the next 3, which are 7, 8, and 9. And then when we get to 15, 2 of those have been removed. So we start off with just 1, 4, and 7, the pages that are labeled 1, 4, and 7. The first one, the fourth one, and the 7th one. Now at 15 minutes, you add the next 3, which are 10, 11, and 12. And then you move to the next time period. But before you do, you have to remove 2. So you start this next time period with the pages that are labeled 1, 4, 7, and 10. Now you add the next 3, which would be 13, 14, and 15. But then you immediately remove 2 of them. And then you start the next time period with 1, 4, 7, 10, 13. You add the next 3, which are 16, 17, and 18. But then you immediately remove the top 2. And you start the next time period with 1, 4, 7, 10, 13, 16. And you add the next 3, which would be 19, 20, 21. And then you immediately remove the top 2. Then you start the next with 1, 4, 7, 10, 13, 16, 19. You add the next 3, which would be 22, 23, 24, and you immediately remove the top 2, and you start the next time period with 1, 4, 7, 10, 13, 16, 19, and 22. Correct? And then, of course, you add the next 3, which are 25, 26, 27, and you go on from there. So at this point, I think you get the hang of it. I think you can do the last few. I'll just fill them in. So I filled it in until all 36 have been added. Now, what I want to do is, now that all 36 have been added, we have to now start talking about what's going to happen next. No more new papers are coming in. Now it's just going to be a clearinghouse. We're just getting rid of them 2 at a time. So I will shift this over and extend this table, and let's see what we get. So at the 55-minute mark, that is when we place the last of the letters, which were 34, 35, 36, correct? And immediately we remove the top 2. So when we get to the 60-minute mark, these are the only letters that are remaining. And there's 12 of them. So there's 12 letters remaining. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then each of these intervals, you're going to remove 2 until there's none left. So they want you to figure out, when was this guy removed? The 13th letter. Okay, let's see. So in this interval right here, the 60-minute mark, you remove 34 and 31. And if you do, what's left are these guys, 19, 22, 25, 28. At the 65-minute time of this question, we remove the next 2, which are 25 and 28. So now you're left with these guys. Then at 70 minutes, you remove the next 2, which would be the 22nd and the 19th. So you're left with these guys. And then at the 75th minute, you remove the 16th and the 13th letter. And that is what they're asking. At what time was the 13th letter removed? It was removed at 75 minutes from the start, which was 12. 75 minutes from 12 is 1:15. So therefore, number 25, the answer is 8. Dolly, Molly, and Polly each can walk at 6 kilometers per hour. Their one motorcycle, which travels at 90 kilometers per hour, can accommodate at most 2 of them at once and cannot drive by itself. Let T hours be the time taken for all 3 of them to reach a point 135 kilometers away. Ignoring the time required to start, stop, or change directions, what is true about the smallest possible value of T? We have to develop a strategy to figure out what is the way that they're going to travel. And I think that is the most challenging part, figuring out the strategy. Once the strategy is figured out, then the math is relatively straightforward. So here is the strategy. So I'm going to draw a few lines and then explain it. So the 3 friends, D, M, and P, all obviously start off at the start, and this whole distance is 135 kilometers to, I guess, the finish line. We can call it finish. And the strategy is as follows. First, 2 of them, let's say Dolly and Molly, get on a motorbike, and they go all the way to a certain point. They get to here. So D and M arrive here. Meanwhile, Polly is walking. So Polly is not staying here. She's walking. So she's somewhere around here. Okay? Now, at this point, we don't know any of these distances. So I'm just going to label this distance X. It's the distance from that point to the finish. Now, this is a very important point. That is what you call a drop-off point. That is where Dolly drops off Molly. And then Molly starts to walk in this direction. So Molly will start walking toward the finish line. But then Dolly goes back to pick up Molly. Okay? So now Dolly's coming back. And by this point, Polly is walked till about here, right? And then Dolly comes back to pick her up. So this is now a pick-up point. Now the distance that Polly has walked from the start to there, I don't know, so I will call it y. Okay? Meanwhile, Molly is still walking. She is probably pretty close to the finish line. Not sure where, but somewhere around there. Then Dolly picks up Polly and then drives her back on the motorbike. So then they all go back together, and eventually they end up at the finish line. So they all end up back at the finish line, P, D, and M. Okay? And they all arrive at the finish at the same time. So let's figure this out. And we're going to use, of course, that formula, speed is equal to distance over time, and any variation of this formula, such as time is equal to distance over speed. So let's figure this out. Let's call this first scenario T1, and then this second scenario we'll call T2, and then this final scenario we'll call T3. And then, of course, the T is the time taken for all three of them to reach point, I guess the finish line. So that T that they're asking about that's in the answer choices is really T1 plus T2 plus T3, because all of them have to reach the finish line. So here we go. What is T1? Well, it's distance over speed. And for this distance, it's from there to there. Now the whole distance is 135. And from here to here, I have labeled that as x. So that distance that the two friends on the motorbike travel from there to there is really just 135 minus x over 90, which is the speed. And then for Dolly, which is the first friend that I really am talking about, T2, her T2 is basically going from that drop-off point back to the pickup point, right? She was here, but then now she's traveling to there. So she goes back like that. So that distance is basically 135 minus x minus y. And again, over 90, because she's still on the bike. And then the last distance is when she goes from the pickup point, right here, all the way to the finish line, and ends up here. So that is going to be 135 minus y all over 90. All right. So I hope that makes sense. Those are the three times for Dolly. And the total, of course, we need to figure out. But the only way we could figure out the total is if we had actual numerical values for x and y. And we don't. So what do? Well, if we don't have that, we have to come up with new equations. We have to come up with additional equations that will allow us to figure out the values for x and y. And how we do that is by looking at the other friends. We'll look at Molly, and then we'll look at Polly. So in the very same way, let's look at Molly. What is her story? Well, Molly initially was on a motorbike until the drop-off point, so that's going to be 135 minus x over 90. Now let's talk about T2 for Molly. Interestingly, for Molly, T2 and T3 is sort of the same because that whole time she's just walking. So we actually don't even need to worry about two different times. We should just concentrate on her second phase, which is just walking, and that's just x over 6. The distance is x and the speed is 6 because they're walking at 6. So that's all there is for her. And then Polly, her T1 is that initial phase where she's walking. So that's actually going to be just y over 6. And then her final phase is when she's on the motorbike and going all the way to the finish line with Dolly. And that is 135 minus y over 90. So there you go. This is a breakdown of all three friends. Now we still haven't figured out the numerical values for x and y, and that's obviously required. So how do we do that? Well, we do that by looking at the times and comparing them. So for example, after this drop-off point, the time it takes Molly to go from the drop-off point to the finish line is this right here, x over 6. But that is the same amount of time it takes Dolly to go all the way back to the pickup point and then back to the finish line. So remember, they all arrive at the same time. So that means this is equivalent to this plus this. Okay? That's very important to this question. So 135 minus x minus y plus 135 minus y, these are both over 90, is equivalent to x over 6. Those times are the same. And in a very similar way, we can compare Molly and Polly. Comparing Molly and Polly, their total times are the same. The time it takes Molly to be on the bike and then walking is basically her entire journey, is the same amount of time as the entire journey for Polly, which is an initial walk and then a motor ride. So that means that 135 minus x over 90 plus x over 6 is equivalent to y over 6 plus 135 minus y over 90. So there we go. We got two equations, two variables. We can now solve for x and y. So let's proceed, and then we can come back and figure out the time, which is right here. Well, this equation, let's start with that one first. Let's multiply through by 90. That will get rid of the fraction. So we have 135 minus x minus y plus 135 minus y. If you multiply this by 90, it becomes 15x. And then let's put everything on one side. 270 minus 16x minus 2y is 0. So if I isolate for y, I get 270 minus 16x. Divide through by 2, you get 135 minus 8x. Okay, let's solve this one right here. Divide or multiply through by 90 and you get 135 minus x plus 15x plus 15y. And that's going to be just 135 minus y. So the 135's cancel, and we got 14x is equal to 14y. So that means x is equal to y. Oh, okay, interesting. Substituting that back into here, and we got 135 minus 8x is equal to y, but y is equal to x. So that means 135 is equal to 9x, and therefore x is equal to 15. And that means y is equal to 15. Okay. There we go. I just got numerical values for x and y. Now I can figure out my times. So keeping this in mind, that t is equal to t1 plus t2 plus t3. Let's just use Dolly since Dolly has t1, t2, and t3. So that's going to be 135 minus x over 90. Well, x is 15, so that's going to be 120 over 90. T2 is this 135 minus x minus y. Well, x and y are both 15, so it's 135 minus 30, so 105 over 90. And then finally, this guy, 135 minus y, so that's 120 over 90, since y was 15. And that is, in terms of decimals, a 1.33 plus 1.166 plus 1.33, and if you add it all up, it's approximately 3.83. So that is the shortest. The strategy was to figure out the shortest, 3.83, and therefore t would lie in which interval? A, right here. So like I said, the strategy, which is this diagram right here, is the challenging part of the question. Once you get the strategy, then you just use this formula to figure out what is the smallest possible value for t, which is the time. Number 25, the answer is A.